record. Now we do it on Kale. We are going to try to cover what we've done on Kale. It will make much sense, I believe, because we are going to cover what happens in the memory as well. This will make much sense, in my opinion. So guys, so why did we use this 2 to the 8 multiplication, 256 multiplication? It will all make sense. I'm hoping so. Okay, so this is just the code I just loaded. Yeah, I have to start my card. Yes, it's on. Now if I load it, no problems, it's loaded. Now I start. So the first thing I calculate was e to the 0, right? Because there's 0 in R0. And I just changed the value to R5 so that I can see that it's working. The e to the x will work. So let me just not get into the function first, jump over the function, and see the result. What do I have in R5? In R5, I have this value. Remember this? We talked about this. So the value at R5 after the function is run is this, guys. I don't write the other one. So this is, guys, in decimals, 256 times 1. So yes, e to the 0 is equal to 1. That was the definition of the function, and we had what we wanted to have. Any questions about this? I'm going to go into the function, but any questions on why this number, this value, is the value that we want to get out? Why is it so? Any questions?
Hocam ne değil miydi virgülden sonrası gibi?
But where is the virgül then?
İşte sıfırdan 1 ile 0 arasındaki sayılar.
Yes, exactly. So where is the virgül in this number? Because that's the result. Where shall I put the virgül?
1,00.
Exactly. And what is this number? It's 1. Let's calculate this number. 1 times 16 to 0 plus 0 times 16 to minus 1 plus 0 times 16 to minus 2. 1 times 1 plus 0 times something times 0 times something. It is 1. Yes, it's 1. Maybe answer to your question. Okay. I'll get into the function, but I'm going to run the next one as well. Clear all drawings. Okay. Now I move 1 to R0, and I'm going to find the function. So after the function runs, what I expect to have is e to the 1 times 256 at R5. Okay. Let's see what do we have in R5. Sorry. I should have. Okay. Sorry. İçine girdi ya. Breakpoint'imiz varmış. Şuraya breakpoint koyayım da atlasın. Okay. Now we have this number in R5, guys. Why do we have this number in R5? This number in R5. I'm going to write that number. Don't worry. So I have 0 to be 6. And what he said was, it was here. This should be e to the 1. What is e to the 1? What is e to the 1? That's this number. Blah, blah, blah. Okay, so is this number really this number, guys? Let's try to find out. Let's try to calculate. Let's do it. 2 times 16 to 1 plus b times 16 to minus 1 So instead of B, let's write a decimal number. Which number shall I write instead of B? What is B in decimals? What is B in decimals, guys, please?
11.
Thank you. 11 times 2 to the minus 1. 6 times 2 to the minus 2. So let me write it more clear. Sorry, this is 0. Arkadaşlar böyle şeylere uyarın ya. Bunların videosu oluyor. İnternete koyuyorum. Rezil olurum bakın. İşimden falan olurum. Lütfen rica ediyorum düzeltin. 2 times 1 plus 11 over 16 plus 6 over 256. Right? So I'm going to do it in MATLAB because öbürüyle yapmak çok üşendim arkadaşlar öbürüyle yapmaya. Let's calculate this number and see if it is really this number. MATLAB'ın da bir açılışı. Bekliyoruz. Okay, so I'm calculating the numbers here. It was 2 plus 11 over 16 plus 6 over 256. Evet, MATLAB. It's something very close to it, right? But not exactly the same. Why? Because of many reasons. Because we have used only 8 bits, 2 nibbles for the precision here. If we have used more bits for the precision, and if we have done this more than 40 times, because you know the formula goes to infinity. However, we did not calculate it to infinity. We calculated 40 times. That would have been better. We are going to do it, guys, today. Don't worry. So I'm trying to say that with some precision, it does calculate. So yes, it is the answer that we were looking for. Or let me check some other. Nerede bu? Okay, let's get back. Evet, bir şeyi kapatacağım arkadaşlar. Birisi, evet, mute. Okay, so we don't have any breakpoints. I'm going to continue in the case where R0 is 2. So I have 2 in R0. And I changed the number in R5 so that I see the change. And I've got this number here, guys. So let's check. So let me write it in red. So e to the 2 is equal to, let's calculate e to the 2 is equal to, e to the 2 is, saçmalamaya başladı. Nasıl? X2 tabii ki arkadaşlar. Eski MATLAB bu. Yes, that's the number. So it is, let me write this number here. 7 point. Okay. So is it really the number that we were looking for? So it's R5. So in R5, I have this number. R5 is equal to 0, 7, 6, 3. And since I was multiplying with 256, that's the sign here. So what do we have here is 7 times 16 to 0, 6 times 16 to minus 1, 3 times 16 to minus 2. Let's calculate this in MATLAB. 7 plus, because it's 7 times 1, 6 over 16 plus 3 over 256. Not bad. Not bad. I could have better precision, but that's all I can have with this fixed point notation. When you use fixed point notations like these, the precisions are not okay, but they're okay. I mean, you can represent them with some similarities, but we can make it better. If we make the fixed point larger, we can make it better. Okay, I'm going to get into the function now. So I'm going to start the program again. So let's start the program again. Okay. F10, F10, and I press F11 to get inside. F11. Now I'm inside. I save LR. I initialize R5. So R5 is 0. R6 is 256. That's the decimal point to, that's, you know why. I compare R0 with 0. If R0 is 0, yes, guys, Z flag is 1. It is 0. Because 0 minus 0 was 0. They are the same. So I jump to end 0, guys. I'm here. I'm adding the value R6, 256 here. And I retrieve the LR value to PC. Now you're here. At R5, you have 1. Actually, it is 256, but it's 1 times 256. Good. I change the value to R0. I go in again. I initialize R5. Again, R6, R multiplier, 256. I compare R0 with 0. It is 1. Not correct. I continue. Now I'll start the loop, the Taylor series loop, which I will run for 40 times. Good. Now R3. I save R0 to R3. R3 is 1. It's going to keep my value here, the input value. Whenever I need it, I'll retrieve this from R3. So n is here, n is 40. I'll make the subroutine factorial calculate n. I'm not going to go into it. I know what it does. The input is at R0. The output will be at R1. So at R1, I have this value, guys, R1. Sorry, guys. R0 was 0 first, guys. Niye böyle oluyor? 28. Allah Allah. Arkadaşlar bir sorun var ama. Neden R1'da 40 faktöriyel yok? Allah'ım yarabbim. Girelim içine var. Yapacak bir şey yok. Morfiler, mörfiler. Hayır, hesaplamıyorsa nasıl doğru cevapları buluyoruz? Allah'ım 50 kere kontrol ettiğimiz şey şurada oluyor. İçine mi girmiş ya? Dur bir saniye bir daha. Pardon arkadaşlar. Sizden 2 dakika rica ediyorum. Çözeyim. Yanlış bir şey yapmayalım. Şimdi burada R7 hexadecimal 28 yani it is 40. I move R7 to R0. Yes, it is. It's here, guys. And I calculate BL factorial. So I have this value. So at R1, I'll have 40 factorial. I don't have 40 factorial at R1. What is the problem? Allah Allah. Bir daha gidiyoruz içine. Arkadaşlar nerede takıldığımı can you follow what I've been missing? Because that's also important. I've seen a problem with the code. I'm trying to debug it. And if you could follow that as well, that would be very helpful for you as well. So you can see what's wrong with the code, right? I send 40 to factorial. And the factorial code says that I have 40. Calculate n is at R0. The result will be at R1. But I don't get 40 factorial at R1. I'm going to get inside factorial, that's why. It initializes R1. It compares R0 with 2. So it is not, because if it is 1 or 0, it will be 1 or 0 factorial, which are both 1. So if they are not, it jumps, but it's not. I multiply R0 with R1. Good. Now R0 is 39, hexadecimal 26. It's doing the multiplication, yes. No problems with that. And as you can see, the number grows here. It becomes so big that I lose it. That's why. it becomes so big. After a couple of calculations, the number becomes so big that it cannot be represented in 32 bits, guys. Which number? So let's see. In 32 bits, the largest number you can represent is this, guys. It is this largest number. So which factorial is smaller than this one? So let's see. Is 10 factorial larger than this number? Factorial bu değil miydi ya? Allah Allah. Factorial neydi acaba? MATLAB'da factorial var mıydı? Yok. Ha, factorial 10. Okay. Factorial 10. Is it larger than 200 to the... No. Is 20 larger than? Yes. 18'de 17 15 12. Yes. If you're using a factorial larger than this value, actually you cannot get it. So what I'm trying to say, guys, in this loop, we are running this loop 40 times, right? And when you're running it 40 times, you have to calculate the factorials up to 40 factorial. However, we are using a 32-bit system, and our system is not capable of representing factorials over 13 factorial. So actually, constructing this loop more than 40 will give us erroneous results. I'm going to be doing this 12 to get better results, guys. I've just figured out a problem in our code. Okay? So I'm going to run the code with this loop only running for 12 times, not 40 times this time. Good. Good. Very good. Okay, so I've got it. I have 7, so I start my loop. Now it's 12. I'll calculate factorial, and I've got this value, guys, in R1. That's 12 factorial, right? And as we went on, I save it to somewhere. Where am I? Yes, R4. Yes, in R4 I have got this value, R0, R3. I'll calculate the power of the value. So I've got 12 x to the 12 over 12 factorial. At this point, I have this. You'll remember the loop, 256 times x to the 12 plus 12 factorial. In the next loop, I'll be calculating x to the 11 factorial. It goes on like this until I calculate 256 times x to the 1 over 1 factorial. And finally, I will calculate 256 times x to the 0 over 0 factorial, which is 256. But this one is not inside the loop. It is here as a final addition. And I calculate it. That's how it works. Okay. After this correction, I'm thinking that we are going to get a better result, guys. Let's see. Let's see. So I'll just jump to it. So I'm here, same result. So that was not a big mistake, maybe. But maybe for e to the 2, we'll get a better result. Let's see if it is a better result. Yes, it's a different result now. It was something else. Kaçtı arkadaşlar bir önceki, hatırlıyor musunuz? 763 müydü? Bakayım, 763 müydü? Yes, it was 7 plus 6 plus 3. So let's calculate it. 7 plus 6 or 16 plus 0 over. So it is this number now, which is a better approximation maybe. So now, guys, I'm going to make everything better for you. Which I'm going to do is I'm going to be using more values for the exponential. How am I going to do that? it's not going to be 256 times. It's going to be 2 to the 12, which is 4096 times. That's why I'm going to be multiplying with 1 digit more. It's going to be 12 and this. This time, the number that I'm going to be having as the result, so we'll have the dot after 3 digits. So it will be like, imagine I've got something like A, B, C, D, E. I'm going to be putting it here because I'm using 2 to the 12 now. It is 2 to the 12 is actually 16 to 3 because 2 to the 4 to 3 is actually 2 to the 12 and this is 16 to 3. Okay, so actually I'm moving 3 positions. The dot will be here. So let's see how it calculates. Okay, let's see. So let's rebuild it, reload it. Okay, so can you see the result at R5? The result at R5 is this. If you can see 0, I'm going to write all numbers. 1, 0, 0. No, it is not like that. It is 1, 0, 0. As you can see, it is here. So where is the decimal point? It is here. So it is 1. Again 1. E to the 0 is equal to 1. Let's continue. I put 1 here. And I've got this value, 2b, 7b. Okay, let's see if it works. So this time, R5 is 2b, 7b. Where the decimal is, this time the decimal is here, guys. So it is 2 times 16 to 0 plus b, which is 11 times 16 to minus 1 plus 7 times 16 to minus 2 plus 11 times 16 to minus 3. Let's make MATLAB calculate this, guys. 2 plus 11 over 16 plus 7 over 256 plus 11 over 16 of the power 2. So I've got this number, exponent 1, but better. So if you increase the decimal precision, you get better results. Okay, any questions, guys? Any questions? Yok mu?
Benim yok hocam.
Şimdi çok sağ ol. Teşekkür ederiz cevaplar için.